This is part 6 in this series devoted to Improv Card Magic. Now today we will be looking at 16 card packets. 16 cards. And so to begin this, what we will need is 3 random piles of 16 cards each. Now this is going to use up most of the deck, as you might imagine. So I'll go ahead and just deal them out. 3 piles of 16 each. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Whoa, look at that. Just 4 cards left over, which is what we would expect. Okay, so we have these 3 piles of 16 cards each. Now, I do want to review something that we talked about in the previous video in which we looked at 14 card packets. And so this is a little system that I came up with to essentially make remembering color pairs easier, okay? So for example, let's say we lay out the cards and from the top of the deck we have a red, 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 black, 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 and so forth all the way to the bottom card, which happens to be black, okay? Now if you remember my system, what you can do to quickly remember how many red pairs you have and how many black pairs you have, and we're going to ignore the color pairs that don't match. So for example, right here we see 2 red cards together. Okay, so if we view this as an AMP, these 2 cards would be, quote, related. So what we can do is we will count a red pair as 10 and a black pair as a 1. So that when we add all of these values, the tens place will simply tell us how many red pairs we have, and the ones place will tell us how many black pairs we have. So for example, we have a red pair here, so in your mind think 10, nothing here, and if we have a black pair, so that counts as a 1. So 10 plus 1 is 11. Another black pair, so plus 1 is 12. So just keep a running count. Plus 10 more for a red pair. So now we have 22 as our number. Nothing, nothing, plus 1 more, 23. So the only number, or the only information we would need to remember until the end of the performance is the number 23. And then when we go to use that number, we'll look at the tens place, which is a 2, and that will tell us that there's 2 red pairs, and the ones place, which is a 3, and that would tell us that there are 3 black pairs. Okay, so we'll kind of use this little system for remembering how many color pairs we have. Okay, so let's go ahead and just move these up. I guess we can just begin with the one on the left here first. And then recall, we're going to have each pile associated with a packet structure. So for the first one, we're free to go with either one of the packet structures. It'll probably just depend on how strong, how surprising it will be to go with a certain packet structure. Okay, so let me try that again here. These are brand new cards, brand new cards here. So I'll see if I can kind of fan them out so that we can see what's going on a little bit better. Okay, that's mildly better, I think. Okay, so if we want to view this as an AMP, which we could, so here we have opposite colors, so you can think of that as a 0, so we don't add anything. A pair of red cards, so that's like a 10, nothing, another 10, so we're up to 20, a black pair, now that's 21, nothing, nothing, nothing. So associated with the AMP structure, we could just squirrel away the number 21, and that will tell us how many red and black pairs we'll have at the end. Why don't we go ahead and look at the mirrored structure of this as well, just to see if there's anything more interesting there. So a mirrored structure, this is where you look at the cards on either end, and then you just come in one at a time all the way to the middle. So if we focus on just color for now, so we get opposite color, oh, they're both red. So if you want to think 10, opposite color, oh, another red pair, so that would be 20. Oh, a black pair, 21. Nothing and nothing, so we would get a 21 associated with the mirrored structure here. What about as an two-cycle structure? Okay, well, this is where you look at the top and bottom half. Okay, so half of 16 here is, of course, 8. So here is the top half right here, and this technically would be the bottom half when the packets turn face down. Okay, so recall with a with a two-cycle relationship, we're comparing the equivalent positions within each cycle. So for example, the queen here, queen of clubs, is related to the three of spades in position, because they're both in the first position of their respective cycles, okay? And then you just go one over each time, okay? So right now, those are both black, so you can think 1 for our counting system. So 1, nothing, nothing, oh, a 10 for being red, so 1 plus 10 is 11, right? Nothing, 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 and then right here we got a 1, okay? Sorry, another 10, excuse me. So that would take us to a 21. Boy, that number 21 is sounding very, very familiar here. Let's just double check that here. So we get a 1, nothing, nothing, and then we get a 10, nothing, 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 and then a 10, 21. Wow, okay. So why don't we, I guess we can just go ahead and view it as, well, I mean, we don't have to go with color either. Now, that's the key. We can look at any characteristic of interest. Oh, wow. View it now as an AMP. I'm not going to rearrange anything. So look at these two. Okay, opposite color, fine. But check out these. 2 red, 2 aces, 2 sevens, 2 E's. Oh, too bad we don't have 2 4s there. Okay, those. Oh, wow, we do. We have 2 4s here. 2 and 8. And wow, so we could go with, it might be fairly strong, we could say we have a 1 pair matching in value, so we're not worried about color anymore necessarily, right? So we have a pair of aces, so 1 matching in value, a second one, a third one, a fourth one. That's interesting. So 4 of these pairs match in value. I don't know. I think that might be fun to go with. So, and you have to realize that for us to know anything about the ending packet after all of the mixing we're going to do, it will be a miracle if we know anything at all. So I'll just write down here. So 4, and we'll say matching card. This is probably writing down more than we need to. I'm being verbose here. 4 matching card value pairs. As long as we can decipher what that means. And so that means there's 4 pairs where within each pair the cards are of the same value. Okay? So if in your mind, I don't know if a person could probably remember that without having to write it down. You just have to realize that for the sake of this video, we're going to do 3 independent routines. Now, normally you would just do one of these. Well, because we're doing 3 of them, it's probably unrealistic for us to remember all of these and keep them straight. So that's why I'm jotting down some notes. But if this is the only thing you're going to do, you would just have to remember the number 4. And remember that it's associated with 4 pairs of cards that have the same value within the pair. Okay, that's not too hard to do. And a way to remember the number 4 is perhaps to just remember that there's 4 suits. Okay, or any way to remember that 4. Maybe there's 4 people in your family, or 4 siblings, or whatever significance 4 might have for you that would help you remember it by way of a mnemonic or something. Okay, think of the 4 seasons. I just thought of that one as well. Except for where I live, there's only 2 seasons. So just remember the number 4, viewing this as an AMP, and it's 4 relative to card value. Okay, now let's come over here, and we'll take a look at this packet. This really is a random packet, and now we're free to look at it as a mirrored or a 2-cycle, because those are the 2 that are left. Okay, we'll assume that our AMP is kind of taken here. We've spent that one. That one's already covered. Okay. So how are we doing here for a mirrored structure, let's say? And anything, oh, this is interesting. Just kind of a quick glance here. These are the same value. That's kind of interesting. Anything that just screams out is like super, super surprising. Well, a couple of things I noticed. Of course, we have 2 7s. That's kind of interesting. We have 2 hearts here. Not much of interest there or here. But these are both clubs, both red, both 6s, and both hearts. Wow, there's a fair amount going on here, but that might be a lot to hold on to, all of that different information. So for this one, why don't we go ahead and use our system here, okay? So remember, we're looking for colored pairs. A red pair counts as a 10. A black pair counts as a 1. Okay, so there's nothing here, but here's a red pair. So think 10, nothing, nothing. A black pair, so that's +1, so we're up to 11. A red pair, so we add 10, we're up to 21. Nothing there. Another red pair, 31. Okay, so if in your mind's eye you want to just remember the number 31, that's all that you would need to hold on to, just 31. And then you just, of course, need to remember how to decipher the information contained within those 2 digits, 31. And of course, the 3 here tells us how many red pairs we'll have at the end, and the 1 tells us how many black pairs, and then all of the other pairs are guaranteed to be of opposite color. So I think that's fairly strong, actually. Okay, well, the last one here is going to have to be a 2-cycle structure that we focus on. Now, in practice, you wouldn't need to restrict yourself, right? It's because we're trying to do one of each for the sake of this video presentation to make it educational for the viewer. But let's just see what we get as a 2-cycle, okay? And it may not be all that wonderful, and quite honestly, it may not be as strong as viewing it as an AMP or possibly a mirrored structure as well. Okay, let me just kind of make sure that these are all readily visible. There you go, okay. Okay, here we go. I'm trying to jog it here. I'm trying to jog it there. I think I've done it. 4, 4. Yeah. Okay, so I have 8. These are the top 8, bottom 8. Okay, so if we want to, why don't we quickly look at it here and just see what we find with these color pairs. I guess we could do that. So we have a black pair, so that counts as a 1. Another black pair, that brings us to 2. Nothing, nothing. We add 10, a red pair, so we're at 12. A black pair, we're at 13. Nothing, nothing. Okay? So it's kind of the flip of this one. It would be 13. 1 red pair and 3 black pair. Why don't we, just for fun, do something a little different this time, kind of like we did before in the last video, where we just kind of randomly mix these face up, face down, and you can have the spectator do this. They can really make a mess. Just flip these all which way and then mix them up thoroughly. Okay, very good. Just, you know, mix them up. Okay, now then we'll just gather these up. Okay, and so what you do at this point is you now just show these. Okay, and the purpose is really just to kind of demonstrate to the spectator that, you know, that these are well mixed, right? With all of the up facing and down facing, you kind of show them to them and go, okay, are you satisfied that we have these, you know, mixed up fairly well, face up, face down, that kind of thing. Okay. Well, what do you see here relative to a two-cycle structure? Well, the break, of course, would be right there. Okay, so if we focus on up-facing pairs and down-facing pairs, where up-facing pairs count as 10 and down-facing pairs count as 1. It's kind of analogous to the red and black. So what we would see here is we have one up-facing. Remember, we're viewing it as a two-cycle. So the 10 and the jack are related by position. They're both up-facing. So think 10. Come 1 over. These are different orientations. Ignore. Here, they're both down-facing. So think of a 1. So 10 plus 1 is 11. Different orientation. Nothing. Nothing. Oh, here we get another down-facing pair, so that would be plus 1 more, so we're up to 12. Now the next pair is up-facing, so we would add 10, so that's 22. And then we would add another 10 for 32. Okay, so if we were to just remember the number 32, and then just know that we're associating the tens place with how many up-facing pair of cards there are, and the ones place with how many down-facing pairs of cards there are, that would be a way to go, where we can essentially, so it's 32, I believe, okay, for that. Okay. Okay, so let's go ahead and move to kind of the second half here. I'm going to slide these over. Maybe this one down here, this one off here. I need to get to the paper underneath. Okay, so I believe this one was for the mirrored, this one was for the two-cycle. Okay, and then this one over here was for the AMP. Okay, and maybe just to remind yourself, what is it about the AMP? Do you remember? We needed to remember the number 4, like 4 seasons. What was it about 4? It's because 4 of the pairs are of the same value within each pair. You remember that? So 4 matching value pairs. Okay, so that's all you need to kind of remember for this packet. Now, since it is an AMP, there's quite a few things you can do with it and preserve that structure or convert it to another kind of structure. So let me go ahead and just bring up our basic shuffles that we've been using during this entire series. Okay, so as an AMP, if you go down to line 21 on the left-hand side of the screen, you'll see the AK, alternate Klondike shuffle. And this is guaranteed to convert an AMP to a two-cycle. Okay? So how this works then is you just deal them out, left, right, left, right. Now I do want to point out that you could actually do what we're doing here, but do it into 4 piles or 8 piles. You can deal out these pairs into as many piles as the divisors of the packet size. Of course, the packet size is 16, and the divisors are 2, 4, and 8. Well, I just did the standard alternate Klondike, left, right, which is fine. but this plus J refers to Klondike shuffling pairs into 4 piles and so forth, and then we can stack those in kind of different ways than just left to right or right to left. So this judicious stacking is something I talk about extensively in other videos on this channel, so that's something to watch for. But here I just did a left, right, okay? Now this is random stacking decided by the spectator. Maybe they want right on left, that's just fine. Now, since it's a 2-cycle, we can perform as many cuts, so random cut like that, or more impressive, we can do a Charlier shuffle, top to bottom, bottom to top, top to bottom. Okay, and I have, as I've mentioned, a separate video on the Charlier shuffle. So all of that movement of the cards is equivalent to just cutting the cards at some location. Well, because packet cuts do not hurt cyclic constructions, and in particular a 2-cycle, this is still a 2-cycle. Okay, now what we're going to do is we're going to do an LR inverse. You can also think of that as an LR quote 8, okay? And so what we're going to do is I'm going to just deal out into 8 piles. Now I won't be able to fit 8 piles here, so we'll probably just do 4 and then 4, okay? But you know, just realize that you can, you know, if you had more space that you can use than the camera view here, you can deal out into 8 piles from left to right. That would be fine. And it might cause fewer problems keeping things straight, okay? Now, technically, this is a DMP now, right? So think about it. If it was a 2-cycle, that's like having 1, 2, 3, 4, 5, 6, 7, 8, and then 1, 2, 3, 4, 5, 6, 7, 8. Well, by the time we deal out 1 through 8, and then we deal out 1 through 8 again, we've grouped together all the quote 1s, the 2s, the 3s, and 4s, and so forth. So this is what we've been calling a DMP. It's right down there, a DMP. So you can freely stack these however you like, or however the spectator would like. So maybe they want this one picked up first, and then maybe this one, that's fine. This one way over here, that would be great. This one down here would be fine. This one down here would be great. This one over here next, that's fine. This one over here would be fine, and then this one next, okay? So what that gives us is it gives us an AMP again, okay? Which is amazing, an AMP again. Okay, now what we're going to do is a push-off even numbers of cards, and this is found on line 19 in the chart on the left. Now since this is an AMP, it means everything of importance happens in pairs. So if I push off any even number, maybe I'll push off 2 there, and then 4 here, and then maybe 2 there, and then maybe even 6 over here, and then 2 here. Okay, we are free to stack these however we would like, or however the spectator dictates. Okay, so maybe they want this one picked up first, that's fine, maybe this one here. So just think about all the free choices we're giving the spectator, because surely these choices make a difference to the ordering of the cards, which they do. Okay, but this particular procedure that we've just used will not harm AMP structures. That's the key. That procedure would destroy mirrored structures and 2-cycles utterly, but not AMP structures. Okay. Now we're going to convert it to a mirrored structure now by way of the mange. And so if you take a look at the table on the left, it's line 13. And that will always convert an AMP to a mirrored structure. And if you remember, the mange shuffle comes in 2 varieties, an over-under and an under-over. And you can give the spectator that choice. So maybe they'll go with the over-under, 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 over. Okay, we are guaranteed to now have a mirrored packet, and once it's mirrored, you can do LR shuffles. Now here, because of 16's divisors, we could left-right deal into 2 piles, 4 piles, or 8 piles with random stacking from left to right. And that's because of the stay stack principle. Okay? Now what we're going to do a little different though is we're going to go ahead and just deal out half the cards and then flip either half. That's interesting. Okay? So think about what this will do. If I deal out half the cards, 1, 2, 3, 4, 5, 6, 7, 8. And so that's called a 50% coating. If I were to follow it up with the rest of the cards being dropped on top, that is, quote, a 50% coating of the cards. Well, if you take a look at our chart on the left, a 50% coating on line 5 will convert a mirrored structure to a 2-cycle structure. Okay, that's guaranteed. That means setting them side by side like this, they constitute coupled piles. What are coupled piles? This is where at each level the piles are related in the way that we noted at the beginning. Well, guess what we're going to do? What we're going to do, instead of just stacking these, because we would get a 2-cycle then, we're going to randomly flip either half. The spectator can decide. Well, since these are coupled piles, if we randomly flip either one, they're now, quote, mirrored piles. What does that mean? That means the card on top here is now related to the card on the bottom here, and vice versa. This card here is related to the bottom of that one there, and it's true as you go up and down each packet. So these are mirrored packets. Well, you already have seen what we can do with mirrored piles, right? We can do this really fun swapping procedure to get our pairings at the very end, right? Okay, so since we have 8 cards in each, the spectators allowed 7 swaps altogether. Okay, and they can allocate those however they like among these 2 piles. So maybe they'll want 4 swaps here. So 1, 2, 3, 4, and then you set that down like that. And then we have 3 swaps left. 1, 2, 3. Okay, very good. That's 7. And then you set aside this pair here. Okay, so this will be one of the special pairs at the end. Okay, so we have 6 swaps left. Maybe the spectator will ask for 2 of them here. 1, 2. That leaves 4 for over here. 1, 2, 3, 4. And then we set aside the new top cards. There we go. We have 5 swaps. Maybe we'll do 4 over here. 1, 2, 3, 4. And that leaves 1 swap to complete the set of 5 for over here. 1. Set aside that pair. And maybe we'll put it over here like that. Now we should have 4 swaps left. So maybe the spectator will ask for 2 on each. That's fine. So 1, 2, there you go. And 1, 2 for that one. Set aside the new pair right there. Okay, 3 swaps total left. 1, 2, we could put all of them here. 3. You can have all the swaps on just one pile if you like. Set aside that pair. Okay, and then we have 2 swaps left. How should we allocate those? Maybe 1 on each. 1, and then 1. Oh no, we have 2. We have 2 left. Yeah, that's right. Yeah, 1 on each. Okay, I said that right. Okay, set aside that pair. Very good. I can't count. And then now we're down to just 1 swap. Maybe they'll allocate it here. 1 swap. And now we'll set aside this pair right there. And then we're left with this final pair right here. Okay, very good. So we have 1, 2, 3, 4, 5, 6, 7, 8. 8 pairs. Now, do you remember what characteristic or what number we kind of stored in our short-term memory, a number, and that number is going to allow us to kind of divine what happens at the very end here. So if you remember, for this first routine, it was the number 4. We talked about thinking of the 4 seasons of the year as a way to remember it. Or there's 4 suits in a deck of cards, however you want to remember that. But what did the 4 relate to? Well, the 4 related to how many pairs we had that consisted of the same card value. Do you remember that? And so what you can do here, now the spectator doesn't know that you know that, right? Or that you remember that. So you can go here and kind of pretend that you're getting some type of message or feedback from the cards and go, well, I wonder how many of these cards match in color, or how many of them match in value, like 2 aces or something. Oh wow, wait a second. I'm getting a really clear picture as to how many of these actually match in value. That's interesting. Let's see, let me focus on that for a minute. Yes, I can see it in my mind's eye. 4 of these pairs consist of cards of the same value. Okay? Now, they may be of different colors, that's okay, but they're the same value. Let's check to see if I'm right. Are 4 of these pairs of the same value? Oh, those aren't of the same value. That's a fail there. Let's see, we need 4 of them, is what I'm claiming. Oh, that's a fail there. We're not doing very well. Oh, we found one. Check that out. In fact, they're 4s. That's interesting. So we found one pair that consists of cards of the same value. Oh, we found a second one. Yes. Okay, we only divined 4 of these all together. We have 2. Let's see, what are these? Nope, that's a no match in value. Let's see, how about these 2? Oh, we got a couple of queens. Yes. So that's a 3rd pair. Oh, we only want one more matching pair of values. See? Okay, what about this one here? Oh, yes, 2 7s. Okay, so what we do not want to happen is we do not want these to match in value. Otherwise, it's blown. Okay, so are these of different values? Well, if I got a correct signal from the cards, they should be of different values. And they are. Yes! So we got matching pair and values. 1, 2, 3, 4. And the others don't. How in the world were we able to do that working together, considering all of the random choices that you made when it came to mixing and randomizing these cards? I think that is just amazing, okay? And it is actually, but it is true that it's just mathematics too, so it's not real magic. Okay, so now this is a mirrored packet relative to the characteristics that we made note of. Do you remember the number that we associated with this one? I believe it was the number 31. Let's just check that. I believe that's the case. The number 31. Now, do you remember what that is supposed to tell us? The tens place tells us how many red pairs there will be at the end, and the 1 tells us how many black pairs. Okay, well, we'll find out if that's right. But before we get there, we're going to give the spectator a chance to just mix these cards to wazoo here. So since this is mirrored, you know that we have the stay stack principle. And so that allows us in particular to deal into 2 piles, left, right, with random stacking decided by the spectator. So maybe they'll stack left on right, that's fine. So we can do that because 2 is a divisor. It divides into 16, okay? Well, 4 divides into 16 evenly as well. So we can deal into 4 piles, left, right. And we can stack from left to right or right to left. My more advanced students know that we can do even more than this. We can also do, and I'll go ahead and just do it, it's called a leapfrog stacking. So you pick up this one and it leaps over its neighbor and lands on top of the 3rd pile. This one here, pile 2, leaps over its neighbor and lands on top of the 4th pile, and then you can randomly stack these. Okay, so you could have done a stacking from left to right, or from right to left, or a leapfrog from left to right, or right to left. Isn't that interesting? Okay, so let's go ahead, and so this is still mirrored. That's the key. So we've done both of those actually. This is still mirrored. Well, we can convert it to an AMP by way of this LR to the negative R. Now, if you take a look at line 23 on the chart on the left, you'll see that we can convert a mirrored structure to an AMP using this very special dealing. Okay, so how this works is you deal out into 8 piles. It's half the number of piles as you have cards. So it's like 1, 2, 3, 4, 5, 6, 7, 8. Now normally what we would do is deal out the rest going 1, 2, 3, follow that same pattern. Well, the LR to the negative R says, okay, instead of repeating the order in which we do it, we go backwards now. This next one goes on the last one dealt, going backwards. Okay, that's all. It's the R in the exponent is meant to remind us of the word reverse. So you reverse the order in which you deal them. Well, what that will do is it actually gives you, quote, a DMP, actually. Okay, and I guess I left that out, but you can freely stack these pairs in whatever order that you like, actually. You can stack these however you like. So this is, quote, a DMP. So you can have the spectator tell you like which ones to pick up. Maybe they want this one next, and then this one down here, this one way down there, and then this one. Okay, now this is a bona fide AMP. Okay, so it really, really is. Okay, now a shuffle that we can perform on an AMP in the case of 4N cards, so a multiple of 4, which is what we have 16 cards. If you look at line 6 on our table on the left, it's called a supercoat. And if you notice there, under structure preservation, next to supercoat are AMP structures, as long as you have 4N cards, which we do. So a supercoat, how does that work? You just deal out half the cards, 1, 2, 3, 4, 5, 6, 7, 8, set the other ones down, and now the spectator is free to stack the left pile on top of the right or the right on top of the left. It doesn't actually matter. It won't hurt the fact that it's still an AMP. Isn't that amazing? Okay, and now we can convert this to a 2-cycle, kind of like we did over here. Now, why don't we do it a little bit differently this time? Because we have this plus J. J is for judicious. So what that means is, in contrast to what we did back here, where we just did left, right, left, right, left, right, we can actually Klondike into 4 piles. You can go 1. So I'm taking the top and bottom off as 1. It's Klondike shuffle. And then we're setting them down into 4 piles. Okay? So this is an alternate Klondike into 4 piles. Oh, I'm sorry about that. I lost the middle one there. There you go. Okay, and so now we can stack these from left to right or right to left. We can actually do the leapfrog stacking if you want. So if you want to go from right to left, the leapfrog stacking would say, okay, this one leaps over its neighbor and lands there. This one leaps over its neighbor and lands there, and then you can randomly stack these. Maybe we'll go left on right. All of those decisions can be decided by the spectator. And what we're guaranteed to have now is a 2-cycle. Okay? Now you know that once you have a 2-cycle, you can do random cuts. You know, we're going beyond what I've written here, but it's on the table. Or you can do Charlier shuffles to your heart's content. You can do as many of these as you like, okay? None of those will hurt the fact that it's a 2-cycle structure. To go from a 2-cycle structure to a mirrored structure, we can actually perform the Bessie 2-2. Now, I do need to point out something special here. So if you look at line 16, the table on the left, the Bessie 2-2, it will convert a 2-cycle to a mirrored structure only if you have a multiple of 4 cards, which we do here, right? So this is wonderful. So what we can do is, so Bessie 1, 2, 2, remember, is where you take the top card off. You do that kind of like twice. So you go 1, 2 from the top. Try not to drop these. 1, 2 from the bottom. Okay. 1, 2 from the top. 1, 2 from the bottom. 1, 2 from the top, 1, 2 from the bottom, 1, 2 from the top, 1, 2 from the bottom. Okay, so that is a Bessie 2, 2. I apologize for these cards being brand new and slippery here. So this is guaranteed to be a mirrored packet now. Well, once it's mirrored, you can do a whole bunch of stay stack shuffles where it leaves mirrored structures alone. One of them is the up jog. It's line 11 in our table on the left. So you can be an even up jog or odd. I think you'll find it easier to do an even up jog. This is where you jog forward the even position cards like this, and then you just strip out the ones that are jogged forward, and then you can randomly stack just straighten that up, randomly stack these according to the spectator's request. It is still mirrored. We can even deal into 8 piles if we would like. So you can go like 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. And now we can do a stacking from left to right or right to left. You can do the leapfrog, which works great. It's just it'll be, well, should I be brave here? I don't know how much I should show you here. What you can do right here is you can stack those on top of those, actually, and then stack from left to right, right to left, or even leapfrog from there. Should we be brave and do that? Okay, so in this kind of situation, you can actually do this. Isn't that amazing? Okay, and then why don't we just stack from left to right? You could do right to left, or you could even do the leapfrog there as well. Isn't that amazing? Okay, so the hope is we haven't destroyed the mirrored structure, and we'll find out if we did in just a moment. Right? And then finally, let's do a LR negative R. We did that near the beginning. It's going to give us, quote, a DMP. So this is where you go, very similar to what we just did, by the way. 1, 2, 3, 4, 1, 2, 3, 4. Do you remember what that little negative R exponent means? It means you go in the reverse order now with dealing them. The second level is dealt out in the reverse order. What does that do for us? These are the exact pairs that we made note of at the beginning. That's what is guaranteed to happen here. Okay, so why don't we, I'm just going to move that pair up there. Doesn't matter how we order these here. Okay, maybe we'll go like that and like this. Okay, so we can see them all, quite well. We have 8 pairs. Now, do you remember the number that there's just one number we needed to remember for this mirrored routine. It was the number 31. You remember that? I can show you here. Well, I don't know if I can without having the cards slide everywhere. Hopefully you remember that. Do you remember that? See 31? Yeah, there it is. Okay, so 31. Well, what is the 31? Well, we wrote down 31 because the tens place, which is a 3, is denoting the fact that we have 3 red pairs. Somewhere in here we have 3 red pairs. And then we had 31. And then the 1 is denoting the fact that we have 1 black pair somewhere in here. Okay, so we have 3 red pairs and 1 black pair, assuming we haven't made a mistake along the way, right? And I don't believe we have, but we'll find out, I guess. Okay, so, and then you can spin this in a number of ways. So at this point, you would just state, well, I'm getting the impression that 4 of these are of opposite color. There's just opposite colors within the cards. And then 3 of them are red pairs. 1 of them is a black pair. Let's see if that's true. So is it true that 4 of these are of opposite color? Well, there's one opposite color. And are 3 of them red pairs and 1 black? Oh, there's 1 red pair. Maybe we'll focus on the red and the black just to see. Oh, there's, oh boy. Oh boy, that's a bit scary. I claimed that there's only 1 black pair. That's all I felt here. So none of these other ones better be black pairs. Otherwise, the universe is going to blow up here. Okay, well, there we go. There's another red pair, so we're up to 2. I sensed that we had 4 of those, actually. Oh, those are opposite, so that's okay. We thought there'd be 4 of those. Oh, here's another one of opposite color. Okay, so what do we still need? We need 1, 2... Oh, yeah, we just need 1 more red pair for this to be correct. And no black pairs. If we have a black pair, we're dead. Oh, look at that. Opposite color. And so, boy, talk about the cliffhanger. This needs to be a red pair for our little intuition to be correct here. I'm sorry about that. I'm pulling up the little pin. That's red, and that's red. We nailed it. There's 3 red pairs, 1 black pair, and 4 pairs of opposite color. And we didn't make a single mistake. How could we actually accomplish that working together? Isn't that amazing? Okay, and then the final one, if you remember, we did some card flipping there, which is just another way to kind of use all of these wonderful tools that we've developed on this channel. Okay, so here's the packet, and we're viewing it right from the start as a 2-cycle. Okay, so 2-cycle relative to the pairs that we noted at the beginning. Okay, well, as a 2-cycle, of course, you could do Charlier shuffle if you would like, right? Top to bottom, bottom to top. I didn't actually list it there because I was running out of things to list. Not enough room there. Or you can do random cut. Spectator can do that. Okay, now. What I'm suggesting here is that we do, oh wow, this is really kind of twists and turns here. Okay, so we're going to do a 50% deal. 1, 2, 3, 4, 5, 6, 7, 8. That's half of them. That gives us 2 piles. Okay, so think about it. What's the nature of these piles? Well, it was a 2-cycle. If you count out half of them, and then if we were to stack this on top, that would make this a mirrored packet. Well, if you have a mirrored packet and you just split it in half, top 8 cards versus the bottom 8 cards, these become, quote, mirrored piles. Okay, so that's something that we've covered in quite a bit of detail in previous videos in this series. So these are mirrored piles. And as a reminder, that means that the top card here is, quote, related to the bottom card down here, and so forth, okay? So what that will allow us to do is the swapping procedure if we would like to. So since we have 8 in each, there's 7 swaps available for the first stage. So you can go have the spectator dictate, tell you how many swaps they want allocated here. Maybe they want 5. 1, 2, 3, 4, 5. We have 2 left to spend, and maybe we'll spend them here. 1, 2, very good. And then you just set aside this pair, as a pair of cards. 6 swaps left. Maybe they want all 6 here. That'd be something kind of unusual. So 1, 2, 3, 4, 5, 6. Very good. Set aside that pair. And then we have 5 swaps left. Maybe they want 2 here. 1, 2, and we still have 3. 1, 2, 3. Set aside that pair. Okay. And then we have 4 swaps. Maybe they'll do 2 and 2. 1, 2. And then 1, 2 over here. And then set aside that pair. Very good. And then we have 3. Maybe they want all 3 over here. 1, 2, 3. Set aside that pair. And maybe we'll go like right here. We have 2 swaps left. Maybe they want 2 over here. 1, 2. Set aside that pair. Very good. And then one swap left. Maybe they'll allocate it there. And then we set aside the top cards as a pair. And then the other two become a final pair. Okay, so we're going to have to kind of uncover the information down underneath it here so we know what we're doing. Okay, so this is, quote, a DMP now. So this is a DMP. Okay, now we are doing something we've never done before. Maybe ever on this channel, actually. So let me just straighten these up a little bit so that we can see what's going on here. Okay. So I don't recall ever doing this, but it's very cool. So what we're going to, this is a DMP, meaning these are the actual pairs that we made note of at the beginning. Okay, so what we're going to do is we're going to build 2 piles of 8 cards by selecting 1 card from each pair. Okay, so for example, let me move this up here and then this up here and then maybe this one over here. Okay, so what we're going to do is I'm going to build up 2 piles by taking 1 from each. Okay, so maybe I'll take this one here and I'll put it over there and that one there. Okay, and so we'll take 1 from each and kind of put that one there maybe, and this one here. Maybe over here we'll put the jack down there and the 10 there. That's fine. This one, you want that one on the right, this one on the left. You want the jack of diamonds on the left, 10 of diamonds on the right. That's fine. Okay, and then maybe 5 of clubs, 2 of diamonds. You want this one over there, and then this one here. That's fine. And then this one here, and then that one there. Very good. Well, guess what we've just done? Now, if you stack these, well, what we did before I stacked them, we created coupled piles. As you go up each level, at each level, the cards are, quote, related. And that's how we got them. We got them from the related pairs. But if you stack the 2 halves, this is now a 2-cycle. Isn't that amazing? So being a 2-cycle, you can randomly cut it. That would be fine. You can perform as many Charlier shuffles as you would like. It won't hurt anything as long as it's a cyclic construction, which a 2-cycle is. Okay, and then we can convert it to a mirrored packet by doing this alternate Klondike, and we can do this into just a left-right if you like. You could also do it into 4 piles or even 8 piles. And then randomly stack from left to right or right to left, or leapfrog stacking. Maybe they'll want left on right. In this particular case, we are now guaranteed to have a mirrored structure. I guess I should point that out on our table. So we were at a 2-cycle, and if you look at the AK on line 21 in our table, it will convert a 2-cycle to a mirrored packet, provided that you have 4N cards, which we do here. So it does apply to this packet size. So here we are, okay? And now what we're going to do is this LR negative R. Remember that? So you just deal into, you go 1, 2, 3, 4, 1, 2, 3, 4. Now, LR negative R, you remember that negative R? So instead of going 1, 2, 3, 4 again in the same order, we go in reverse order. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so this will now be a DMP. There it is, DMP. Let me just show that. But don't stack the pairs, a DMP. Now, if you randomly stack these according to the spectator's request, maybe they want this one next, and then maybe this one goes on top. They can even put some on the bottom. Maybe they want this one on bottom, this one on top, this one on top, this one on bottom maybe, and then this one on top. Okay, that's fine. You can put it anywhere. Okay, and so now where we are is we're at an AMP, and so to quote finish, what we're going to do is something that I don't believe I've done. Maybe I did it once in the last video. We're going to use the up jog. So this is an AMP, we're going to up jog that. Now, if we were to just do an up jog with random stack, what would happen to an AMP? So look at the chart there. So up jog is on line 11. So an up jog will take an AMP to a 2 cycle, okay? But we're not going to stack the halves. Well, if we don't stack the halves, then we'll have coupled piles. That's why we have a CP there. Okay, so I'll just do, let's say, an even up jog. So we'll just push forward the even position cards, okay, and then we'll just strip those out. And then we'll go ahead and just set that down as one pile. The remaining 8 cards is the second pile, and now these are guaranteed to be coupled piles. Well, that means at each level they're going to be the special pairs. Now, do you happen to remember what number, well, maybe we should finish this first, but think about what number did we squirrel away that would be helpful in reminding us how many pairs of face-up cards we would have versus pairs of down-facing cards versus pairs of cards where there's one of each, an up-facing and a down-facing. Do you remember the number that we remembered? I believe it was 32. Yep, there it is, 32. I guess you could have this written out as a prediction, namely that there'll be 3 up-facing pairs and 2 down-facing pairs, and the other 3 pairs will be one of each. Okay, so you could have had that as a written prediction, set aside, and then you bring it out at the end. Or right now, if you've remembered the number 32, you can say, we're to the end of this very long mixing procedure in which you've made all of the important choices, which you have. Well, I have a feeling I know what's going to happen. What we're going to do is we're just going to pair these up at each level. And my prediction is that when we're done, there's going to be exactly 3 pairs of up-facing cards, 2 pairs of down-facing cards, and then 3 pairs of cards facing the opposite way to each other. So there's an up-facing and a down-facing, okay? So let's see how we do here. So we're going to have 3 up-facing, 2 down-facing, and 3 mixed, essentially. So here, this is a pair that's not up-facing or down-facing. It's both. So there's one of those. Oh, here's an up-facing. Now I'm pretty sure we're going to have 3 of those. Let's just see. Oh, here's another mixture of up-facing, down-facing. Oh, here's another pair of up-facing. Oh, we're up to 2. I predicted there would be 3 of these, and then 2 down-facing pairs. Oh, yep, right here we have a down-facing pair. Okay. Oh, and here is another mixture. We said there would be 3 of these, whereas 1 of each, right? And then we put these off together. Here is our third and final up-facing pair, just as we saw. And here is our second and final down-facing pair. Okay, so that's just another way to use all of the principles and ideas and relationships here and relate it to cards being either up-facing, down-facing, or a mixture. Okay, so that is the final routine for this 16 card presentation. Okay, so I appreciate you watching and encourage you to watch other videos in this series, and certainly take a look at other videos on the Hidden Structures channel. So thank you again for watching.